And so Sam over at Agilent has created a way to do this. So Sam, I'm going to turn this over to you and let you kind of show us real quick how your tool works for generating an SBOM from LabVIEW. Just as kind of background, an SBOM is a software bill of materials that is a list of software that you can get from a vendor that says, this is all the software I use to build what I'm delivering to you. And that way the IT team, if there's an attack, 3 years from now, and they wonder, did they attack any of the components that we are using, you can go and look real quickly in this list and say, oh yeah, this component we're using is on their attack list. So we need to replace that component or replace that software or protect that software somehow. So that's what an SBOM is. I'm going to turn it over to Sam now and let you show us what you have done with regard to that.
Sure. Before you steal too much of my thunder there, Steve. Great. So yeah, hopefully you can all see the slides okay, like a thumbs up or something. Yeah, all good. Great. So yeah, I'm going to talk you through a little bit about kind of a recipe for secure software. And yeah, as Steve mentioned, the software bill of materials, but I'm also going to show you a little bit of how that kind of fits into the, the overall kind of development process as well. So yeah, this is I think my third time presenting at the summit. So yeah, always glad to come back. Let me move on to the next slide. Yeah, again, I always throw this slide in there of I don't consider myself an expert in this. Like everyone here, trying to navigate security and test systems, I'm just kind of sharing, stuff as I find it out and what I find, interesting. But these don't kind of represent the views of my employer necessarily. So, usual sort of caveat there. So our adventure continues. I think it was September 2023. I presented about secure software development, in LabVIEW, and I'm going to kind of pick on one part of that and kind of show the progress that I've been making. So yeah, I won't touch too much on what an SBOM is, as I think Steve's kind of covered that quite succinctly, but I've got some free stuff for you, so who doesn't like free stuff? And yeah, also to kind of close the gap and see how we can use that software bill of materials, as Steve said, to kind of identify vulnerabilities in those components, and I've got a little demo of a tool that we're using internally as well. So yeah, for those that didn't see my presentation at GDevCon or the previous summit, it's available on YouTube. And yeah, we talked about kind of a framework and a process for secure software development. And I really like this picture at the bottom right of unburying our heads from the sand as LabVIEW developers and test systems engineers when it comes to software security and test system security. This was kind of like one of my final slides, which was, how do we make LabVIEW a first-class citizen for security? And I kind of posited if, I got my highlighter out and I've scribbled all over this. So, Hunter's very, thankfully going to talk a little bit about, static analysis tools, which was one of the, concerns I raised. And yeah, I think Tim's going to show off some other tools that he's, found and made use of. But today, yeah, I'm going to be talking about the software bill of materials and how we kind of close that loop of, now we know what's in our software, which is the software composition. How can we analyze that to, find vulnerabilities and get more awareness around what it is that we're using in our software. Why, I think Steve touched on this, things like these White House executive orders say, you must produce a software bill of materials. All of the kind of secure development guidelines, include some aspect of, you should know what goes into your software that you're giving to your customers and you're including in your products. Also covering things like internal license compliance. So, you may have internal rules around, not using restrictive open source licenses in any software or test systems that you're redistributing. And also, it's kind of it just feels right and it feels better, right, to know that the software that you're, shipping, you're using in your test system, doesn't have any, major vulnerabilities in it. across the board. And I think this is the same attestation that Steve was talking about. There's two lines at the bottom there of making a good faith effort to maintain trusted source code supply chains by using tools or processes to address the security of third-party components and vulnerabilities. And so, I think as of September 2022, you or someone in your kind of corporate structure would have to sign that to say, you attest that that is true and part of your software development process. So moving on to the free stuff. Funnily enough, Steve used the same picture from the Cyclone DX website of what goes into a software bill of materials. But yeah, I've kind of been working on a toolkit for LabVIEW to generate a software bill of materials, for a LabVIEW project. So the format that I've chosen is something called Cyclone DX, and yeah, that's a specification for a type of SBOM, and I've chosen to use like the JSON, the kind of the JSON representation of that. It's an international standard. So again, rather than rolling our own, let's kind of join the rest of the sort of software languages and the software security community and use what they've already kind of developed. And there's also the other advantage of this is that there's lots of support available for other third-party tools and other things that you can use so that you're kind of speaking the same language. When you've got a LabVIEW executable or a LabVIEW test system, also talking to perhaps some code that's written in C# and they're already they've been doing this generating SBOMs for years. At the moment, it supports like a number of different component types. So VI packages using the VIPM API. There's some limited support for NI packages, and I'll kind of explain that a little bit. But it can also do things like, pull in your dependencies, things like, NI Visa, the LabVIEW runtime, either from the NI package list or from your kind of installer build specifications of your LabVIEW project. Also show off a little bit, thanks to some pointers from Tim, looking at also including support for things like DLLs and .NET assemblies as well, so that we can include those third-party libraries in what we're doing. There's some project scanning support, but I'd say it's very much a work in progress. And yeah, unfortunately, there's no way to, as far as I'm aware, there's no way to get a list of what my NI package dependencies are for a particular LabVIEW project at the moment. So yeah, at the moment that's kind of a manual selection of which packages you think you need. At the moment, like primarily intended for kind of CI/CD use, so running as part of a build pipeline. But yeah, I'm also starting to kind of like think about what a GUI tool or an SBOM viewer might look like for LabVIEW. And yeah, my employer has very graciously said that I can share this with the community as well. So it's over on GitHub if you want to have a play with it. And yeah, once it's a little bit more mature, I'll publish it to the VIPM API as well.
So just a couple of comments here. So there are two formats for SBOMs, for Cyclone DX and SPDX. And we find that for vulnerability analysis, most people prefer Cyclone DX. And so you've chosen to go with that format. And just one comment is that when I first started thinking about SBOMs, I thought, well, it's a text file that has a few lists in it, right? But there's so much information, and it's all optional information, so it needs to be one of these markup languages, and JSON is the preferred method for that I've seen. So yeah,
cool. If I just switch across to LabVIEW then. So again, this is all kind of very like work in progress. I'm not going to spend too much time diving into it, but I've got a tool here that allows me to see a list of all the installed NI packages. I can select the ones that I'm interested in, so the ones that I know my application uses, and I can use that to kind of generate a list that I can then include in my software bill of materials. What I can then do is I can switch over to here and I can select my project. I can select my VIPC file, and again, I'm kind of working on simplifying this a bit. I can press run and that will spit out a a bill of materials in the Cyclone DX format. So yeah, kind of this top section is all about the metadata. So it's about your software and who you are as the author of the software, that it's an application, who it is, and also how to kind of uniquely identify that piece of software, so that if someone were to discover a vulnerability in it, they can kind of identify that. And I'll talk about that a little bit later as well, about how we as a LabVIEW community, how we kind of identify these components in the LabVIEW world. And then down here, we can see that, this particular library that I'm using uses the OpenG error library, and we can see a link there to that and what version it is that we're using. So this is kind of building up those, that picture of what components my software is using. And I've got another example here. Where I've included a few more items. So it includes the licensing information, if that's available in VIPM. I've got some stuff from the NI Tools network. I've got my LabVIEW runtime engine as an NI package, and I can see the version of that and the details and who to get in touch with if something goes wrong. And then, I can also include things like .NET assemblies and the hash of those assemblies, so that they can be, you can kind of compare two versions of the same thing and check that, it's the same, carries the same signature. And we'll kind of talk about the relevance of that a little bit later as well. To show you what the code looks like. This is kind of the code that generates that example, which is I create a new software bill of materials. I can add my kind of metadata about that bill of materials, when it was generated, who generated it, who the supplier of the software is. I can then add the details of my software application. So who created it, what's its version, all that kind of good stuff. And then I can basically add the components to my bill of materials. So if I've got a VI package, this is the kind of data that comes from VIPM. If I've got an NI package, I can add that in. I can add a DLL and and .NET assemblies and things like that. And then finally just flatten that to a JSON. A JSON string, and then sort of by convention, what you would typically do is write that to a bom.json file in your kind of repository root, and that's kind of the standard convention for kind of storing that bill of materials in your source repository. Cool.
Very cool. So the list we saw, this is all software components that are installed with the components that you've identified as part of your code, right?
Exactly. Yep.
You might say, I'm calling DACMX, and then it's going through and saying, well, DACMX calls all of these things and all the things that need to be installed with that.
Exactly, yeah.
That's really cool. Are you getting that from the license files that are installed with LabVIEW? Is that where you're getting that, or?
No, so I mean, at the moment, that's the bit that's a little bit manual. So obviously, I can get a list, the tool that I have here, this gives me a list of every NI package that's installed, but obviously I only want to include things in my software bill of materials that my project is actually using. So at the moment I have to kind of manually select those dependencies to kind of include them. But if you're using a LabVIEW installer, if you tick the box that says automatically include these additional installers, then I can pass that data from the LabVIEW project to give me, the things that LabVIEW thinks it also needs to install, like DACMX or the Visa runtime, the LabVIEW runtime, and include those in my project. Okay, so you're getting the dependencies from the project file then. Yes. Yeah. Okay, very good. Yeah, it's about being specific, and then obviously then pulling in like the third-party, LabVIEW components that we use. So any packages from the NI Tools network, any third-party DLLs we're calling, and making sure that all of that kind of stuff that's in our dependencies is captured in our SBOM as well. Cool. So yeah, that's a little like kind of brief demo to the toolkit. Some of the stuff I've shown off today isn't kind of pushed to the GitHub repository, but yeah, there is some stuff on there, and I'll make sure I push that stuff up fairly soon.
Cool.
Cool. So closing the loop then. So now we've kind of figured out what's in our software. We've got our, fancy schmancy software bill of materials. But how do we know what's listed in there, is secure and is safe to use? So this is where the step called software composition analysis comes in, and is kind of the next step, which is where we analyze that software bill of materials and identify, any vulnerabilities that may be, present in them. Other languages, they've got tools galore for this. There's a few listed there, BlackDuck, SonarQube, but obviously none of them really understand our LabVIEW source code. So, these tools, they look at your code, they look at your package lists, and they automatically build that bill of materials for you, and then look at, are there any vulnerabilities present? So what I'm trying to do here is kind of close that gap so that, LabVIEW can kind of work with some of these tools and start speaking the same language. So I've got a little demo here of BlackDuck, which is one of the tools that we use internally. So I'll kind of press play on this little video and talk through that. So this is the local scanner. So typically the way you would use this is you would point it at your source code repository, and it would just periodically, check out the code, scan it, but you can also kind of run it offline locally on your PC. So what I've done is just kind of selected a folder of one of the packages I've got installed. I have to kind of link it to the project in BlackDuck, and also kind of assign the version number that I'm testing here. It'll then run off and start doing its automated scan. Which it'll take a few minutes, and what it's doing is, if it could understand LabVIEW, this is where it'd be looking at all the source code files. But for other languages, it'll look at the solution file, it'll look at your NuGet packet lists, package lists, and any DLLs or anything else that you're using in that repository. In this case, this is a package that does a HTML to PDF conversion, using quite a popular library for this that I know happens to have a known vulnerability, in the version that I've got. So what this is going to do is pick up that DLL and hopefully tell me that it has a problem.
So this is scanning text code. It's not scanning your LabVIEW code, is what you're telling us, right?
Exactly. Yeah. But what it will do is, if you have some like DLLs in your project, in your source code repository, say you've got another team that's given you some some DLLs or some .NET assemblies, it will scan and recognize those. It will pick up on those. But where it says the kind of in the attestation requirements of kind of best efforts, and I don't really think it's in the spirit of the attestation to run the tool on something that it doesn't understand and say, oh, it's got no findings, so my code is secure. It's not quite the spirit of that. So once you've run the tool, you get a kind of a dashboard that looks like this, where you have a it'll tell you how many what security vulnerabilities you have, the number of things that are not compliant with your license, and your sort of operational risk, of things that your company is particularly interested in. So now I refresh that, I can see that it's scanned version 1. It's picked up the HTML to PDF library. It's picked up its library information, and then I can kind of browse through here. Security risk, license risk, operational risk, for that particular version. It's picked up that particular version, and then I can click on it and say, oh, yep, that thing has got one vulnerability, and I can click on it in a bit more detail, and it'll give me the CWE score, the CVE that's associated with it, and it'll also give me kind of suggestions on how I can resolve that vulnerability as well. So what I'm working towards is having something similar like this, that I can use our existing tool to work with LabVIEW. Touched on the DLL stuff, but it's obviously unable to read LabVIEW code. However, if you produce the software bill of materials yourself, you can push that into BlackDuck. So even though it can't understand LabVIEW code, I can push my software bill of materials that I've generated using my toolkit into BlackDuck, and then it can then analyze that. these tools, they have their own, where they kind of make their money, and their kind of secret sauce is that they have this knowledge base of known vulnerabilities, pulling in data from external, public vulnerability disclosure sites, as well as internal databases and things like that. So yeah, what we want to do is kind of pick things up from there. And yeah, they link vulnerabilities through something called a package URL, which is a is something for other kind of NuGet packages and things like that. There's a standardized specification for referencing those packages in a common way. And I touched on the license compliance checks. I'll skip over this quite quickly, but essentially what I'm trying to do is add the VIP, like the VI package format, and the NI package formats to the package URL specification. So this is so that we can, the JKI and NI, we can, as LabVIEW developers, we have a single standard for referencing these kind of package formats, so that we can uniquely identify a package, across the tools network, across something that somebody's generated locally. And then if we were to, discover a vulnerability in that package, we can publish that, or the author can publish it to the, CVE database. And then these tools can match, based on that, package URL. So in theory, the way this works is, a vulnerability gets published against the package URL. Our pipeline generates that software bill of materials and uploads it to Black Duck, and then Black Duck then does that search, matches on that package URL, and says, hey, that library you're using from the tools network, it has this vulnerability. You might want to update to the new version where that's been fixed. And that's how we kind of close that gap around, not just knowing what's in our software, but also how we kind of identify vulnerabilities, and address them as well. So quickly summarize, software bill of materials, you're probably going to need to do it at some point if you're not already. I have a free toolkit, and there's a little bit of a kind of a sneak preview there of how Black Duck can be used with our software bill of materials to kind of identify vulnerabilities. Awesome. And that's me done. Thank you.
There's one question in the chat asking about what sort of security level does it check, and is there an international standard that it follows? I assume he's talking about the SCA part of it, which we haven't really developed yet. The Black Duck, I think, follows really all standards. I think they have. Black Duck's not a cheap tool, right? It's a many thousands of dollars, $10,000 or $20,000. So they're doing quite a bit of work in that to make sure that it's looking for all of the CVEs and all the things that are out there. And if they find some standard, they're trying to comply really with all of them, I think, at that level.
Yeah, I think really what you do is you have to set within Black Duck, you set an organizational policy. So like for things like licenses, your organizational policy says you cannot use, certain LGPL licenses, or you cannot use, anything that's published by this license. And you set that at an organizational level, and then it checks, against that. And I think it's probably the same for, all it's really there to do is to flag to you that these things have a vulnerability. It's then down to your organizational policy as to what are you going to do about it, right? It's we've identified a problem. What are we going to do about it? Are we going to remove the component? Are we going to, update it to a version that doesn't have that vulnerability? Or it may be that you say, well, if it's below a certain, CVE score, you just say, we'll accept that, right? We accept that as a risk that yes, it's there, but we're happy to accept that level of risk. And I think that's on a project, depending on who your customer is, or at an organizational level.
All right. Very good. Thank you very much, Sam. Appreciate it.